Howdy folks, John here from rchelicopterfun.com. It's finally here, the OMPHobby M1. One of the most highly anticipated micro collective pitch RC helicopters of 2020. And if its performance is anything like its bigger brother, the M2, could potentially be one of the best micro collective pitch RC helicopters ever. I want to thank Dale at Buddy RC and OMPHobby for agreeing to send me the M1 so we can all have a look at it together, take a deep dive into it. And as usual, there will be product links below in the description. We've got lots to cover. Let's get into it. Unboxing the M1. Just take a quick peek at the sleeve here. Like the M2, the M1 comes in 3 color formats. They're the same as the M2, the charm orange, the dull purple, and the racing yellow, which is the one I chose. But they're all really bright. That's another reason I like OMPHobby's Helis. They pick nice, bright, vibrant colors that are easy to see, not like a lot of other brands. And on the back here, just let you look at the dimensions. You can pause the video if you want. We'll check a couple more when we're doing the review. Like the M2, the M1 ships in this nice protective foam case, which doubles nicely as a carrying and storage case. As you can see, really wonderful presentation. Looks like we've got spots for 3 extra LiPos if we wanted. It comes with some tools and it looks like a few spare parts here. And then there's this other little compartment for other parts or whatever. No instructions at all and not really much online. If you've already got an M2, it's pretty much identical as far as operation and setup. Of course, it helps tremendously if you understand collective pitch RC helicopter setup. Heli itself, identical looking to the M2s. The same looking canopy and everything, just smaller. And that's essentially what an M1 is. It's a 100 size. We'll check the blade length so we can get the exact size. I'm guessing, just looking at it, it's about a 130 size Heli. 120, 130. And the main reason I've been anticipating the M1s is one of my favorite helis to fly with and practice with in my yard has been the T-Rex 150X. I have put so many hours on this little guy and it's just been a wonderful little helicopter, but it is getting tired and I definitely needed to get something to replace it with, and this is going to be the one. Now the M1 is just a tad bigger than a T-Rex 150X, but certainly if you've got a 150X and it's getting tired and you're thinking of getting a different heli, definitely consider an M1. It should be on your short list. While we're on the topic of size comparison, just thought I'd show you the M1 next to the M2 so you can see the size difference between the big and little brother here. Another heli that a lot of people are probably going to be comparing this to is the Eachine E160, which is actually a little bit bigger. Let's check the blade length. As you see, it comes with a little blade holder. And let's just do a blade length check so we can do an actual apples to apples size comparison. So going from the bolt hole to the end of the tip, we're looking at about 125 millimeters. So yeah, this would be 125, usually sized up to 130 size heli. So hopefully that'll give you an idea on size. Let's start looking a little closer though at this thing. Canopy is not fiberglass like the M2s. It's a polycarbonate, but it is a thick polycarbonate. Definitely way stronger than the Eachine here and the T-Rex 150X. This is a much heavier plastic and the paint job is really nice. Graphics, super crisp. There's the nose shot of it, very symmetrical, nothing's warped or anything. Really nice looking canopy. Again, same exact profile as the M2 canopy. The tools and little parts that came in that little baggie, you get 2 little screwdrivers here. One's a tiny little 1mm hex drive, and the other, for some reason, is just a small flat blade. And the reason I don't understand that is because the majority of fasteners on this helicopter, they're all Phillips, the majority of them. And then there's 1.5mm hex screws on the bigger ones. And then the really tiny hexes are the 1mm. So I can totally see why they'd include the 1mm hex. It's a size most people don't have. But other than that, you're going to need a small Phillips screwdriver and a 1.5mm hex driver as well. So first we'll go over the LiPo battery. It's a 2S, 350 milliamp hour, and it's got a 3-pin JST XH plug on it. This acts as both your charging plug, balance plug, and of course power plug for the Heli. Well, talking about the battery here, I thought I better cover charging real quick because for some it's going to be a head scratcher. You know, how do you charge a battery that's only got a balance lead on it? You know, most LiPo batteries, they'll have the balance lead, of course, that plugs into your balance port on your charger, and then of course the main power plug. So you're charging through the main, balancing through the balance. If you've already got a T-Rex 150 or 150X, you've likely got one of their chargers, which will certainly work fine for the M1 battery packs. If you don't have one of these, if you do a Google search for T-Rex 150 or 150X charge harness or charge board, you're going to see things like this pop up. And this is a combination charge and balance board specifically for packs that only have the balance leads on them. And the idea is this will plug into your charge outlet on your computerized charger, your two bananas, and then the plug would into your balance lead. And you can charge that way. You can also make your own harness. It's not that difficult. Leave a comment below if there's enough interest. Maybe I'll do a video on building a charge harness for these things. Now, battery size is very specific because it is a friction fit in the little battery holder here. Size on this, I think you're pretty much going to have to use the OMP packs because of this size being so critical. But for length, we've got roughly 43 millimeters. For width, about 19.5 it looks like. I don't think 20 would fit. It might, but it's tight in there, and the height is 13 on the nose, pretty much. Just over 13. So that's the battery size. If you happen to have something like that, it might fit. I've checked all my little 2S packs and none of them are the right size. The battery plugs into a 3-pin JST connector, of course, at the front of the ESC board. This connector is, I don't know if you can see that, there's a nice copious amount of filleting adhesive on both sides of that connector to keep it nicely bonded to the board. So you're not worried about the solder connections coming loose over time. The ESC board is at the bottom. So this is the ESC and mixing board for both the main brushless motor and the tail rotor motor, which is also brushless. We'll get to the motors in a bit. Very interesting, on the ESC board, they've got little threaded standoffs. They're using little ring connectors screwed onto those standoffs, and the motor wires are soldered onto the ring connectors. Wouldn't be a bad idea every now and then just to check the tightness of those little Phillips screws so you're getting good electrical conductivity through the standoffs and the motor wires. And then on the other side, there's the plug for the tail motor. There's the tail motor wiring. The ESC is connected to the main flight control board through these two 4-pin standoffs on either side. And there's also screws holding the main control board down on both corners here. And the control board has got the OMP protocol receiver built in. Now I'm going to be binding mine to my OpenTX radio with the OMP protocol that is now available for the multi-protocol modules. I've done videos on that before on the M2s. I will link to both of them down below and in the description if you wanted to take a look. This is going to be set up exactly the same way. Binding is identical. This little control board is pretty much identical to the M2 V2's control board. To properly show all that's going on the M1's flight control board, I thought we'd do a close-up and go through it real quickly. Lots going on here. At the far left here, we've got the 3 swash plate servo plugs. Just above them, we've got the S-Bus serial communication plug. So any micro receiver that's outputting an S-Bus signal, you could use with this helicopter. And then we've also got DSM, so you could run a Spectrum satellite DSM-2 or DSM-X receiver if you want to use Spectrum. And of course, it's got the internal OMP receiver built right into the board. That's what this little bind button is for. You hold the bind button in. We'll show that when I bind it to the radio. And then the tactile switch to the right of the bind button is to go into the settings, to the parameter settings for the flybarless system. And we've got two LEDs lit up right now. Blue solid indicates it's communicating with the radio, and the red above it is what stabilization mode it's in. When it's flashing, it's in normal gyro stabilization, no self-level help. If it was lit up solid red, it would mean that the accelerometer help was turned on, so you'd have self-leveling. And to enter setup mode for the flybarless unit, you just hold the set button in here for about 3 seconds. And just like the M2, V2, and Explorer, this is exactly the same. You've got all these different settings for rudder, elevator, and aileron, and then you can also center the servos and set your collective pitch range. And you use your transmitter sticks to either increase or decrease the value. Out of the box, it comes at level 5. You'll see it's flashing 5 times. You've got a range from 1 to 9, and we can just cycle through these. So that first one, we would be setting the speed or the yaw rate of the rudder. Here we are setting the gyro gain of rudder. And now we're at elevator. We'd set the speed, agility, or gain of elevator. And same with aileron or cyclic roll, speed, agility, and gyro gain. And then the other two, of course, servo centering, and setting your collective pitch range if you wanted to alter that. And just hold it in for 3 seconds to get out of it. The one thing I have noticed, now I don't know if this is because this is an early version and maybe they just missed it, but the antenna wire for the built-in receiver, it's just soldered to the board, but there should be some antenna glue here for strain relief. If this keeps flexing, those wires over time are just going to fatigue crack, and this antenna wire is going to break off. Moving back, we're at the heart of the helicopter, and this is a really neat design. Of course, the big draw to all of OMP's small helicopters is their direct drive motor technology. The big brushless outrunner motor is direct driving the main shaft, no gears to worry about. Just like the M2, V2, and the original one, motor is anodized to match the canopy color you choose. So this has got the yellow anodizing for the yellow canopy. And then the real core heart of this is this nice single piece of aluminum in here that's got the bearing blocks, both the upper and lower bearing blocks, so your main bearings are in there. And it's also got the mounts for all 3 your ECCPM servos, 120 degree placed, of course. And then the motor mount is screwed to that center core, and then the motor mount is screwed to the plastic frame just with 4 little hex screws. So you can take this whole assembly out, just take the 4 hex screws out, and that whole core section comes out. Makes it really slick to do maintenance and part swaps on it. Servos are little DS2045s, digital coreless, of course. Just looking at the mechanical setup, servo arms, we've got them centered, all 3. And as we can see, the swash plate, dead level, side to side, and front to back. So they've done a really good job there. Note, no adjustable links from the servos to the swash plate. So no mechanical adjustment at all on the M1. The only adjustment you've got is your servo centering programming through the flight control board. Neat, the anti-rotation bracket. It's a nice forward swept design. Pretty cool looking. And there's your metal canopy mounting pegs. They're quite sharp. Just little silicone grommets on the canopy. Wouldn't hurt to put a little silicone grease on the end of those to just make it a little bit easier to pop the canopy on and off. And like the new M2 V2s, nylon landing struts, nice and flexible and strong. Plastic frame with that metal core, of course, and the blades are a nice plastic carbon composite, full metal head, DFC linkages to the blade grips. Okay, moving down, we've got an aluminum boom, that same teardrop shaped as the new M2 V2. Very strong, certainly more robust than the little T-Rex 150's little aluminum boom. Plastic tail fin and motor mount, all one unit. Very flexible. Tail rotor plastic, very flexible as well. There's the little brushless tail motor. Again, color anodized parts on it to match your canopy. Another thing I really like about OMPHobby's Helis is the motor wiring is nicely protected. It comes right out of the back of the motor, right up the tail boom. So no exposed wiring anywhere to get caught and torn. Tail rotor is actually screwed into the shaft, so it's not just slid over. Binding the M1. As I had mentioned, I'm just going to be binding it to my OpenTX radio, in this case the Radio Master here, using the internal RF module with OMP's protocol, so using their internal receiver. So we just plug in the helicopter and you'll get a little red LED and then a slowly flashing blue LED. There's a little tactile button. You want to push the back one down for about 3 seconds. Just hold it pressed in. Okay, and when it's in bind mode, the little blue LED will start flashing fast. Now turn on your radio. If you've already got an M2 helicopter programmed into your radio, this is going to be really easy. I just copied my M2 V2 and then just renamed it to OMP M1. And we're going to have to go into the model setup here. And we'll scroll down till we get to the RF setup. So here, you can see we're using the internal module. Hopefully that's showing up. And it's the multi-module in the OMP protocol mode. And we're just going to dial down and go to bind. And once we bind, that blue light should go solid. So we're binding it. Starts flashing slowly. There it goes. It's bound already. Swash plate jumps a few times, you get the beep from the motor. And we're rocking. And again, we'll just check the setup. So tilt the heli left and right, swash plate moves in the opposite direction. Stabilization seems to be working right. That almost seems too aggressive, but we won't know until we fly it. And if we go into the radio here, let's just look at our outputs. And you can see my outputs all at 1500 centering, 100% in both directions. And let's just check what the collective range is real quick. It looks like we're producing exactly 0 at mid stick. Full high, full low, looks symmetrical. Where's my little wedge pitch gauge here? So we'll go full high. This is a 10-degree wedge. Well, it's 20 degrees, but that will show, that would indicate a 10-degree collective range on the high and on the low. So out of the box, it looks like it's producing plus minus 10 degrees. My normal mode, I'm producing just a little bit of negative and probably about +9 or so positive. So we'll see how it flies like that. It's snowing out right now. Might have to do my first test flight in the garage here. Before going for our test flights, I figured I better address this antenna. So I've got the little dollop of antenna fixing glue on there just to provide some strain relief. I'd actually be interested to know if others M1s, when you get them, if OMP has maybe started doing that and they just missed it on mine. I realized we never checked the weight of the little guy. Bare bones without battery or canopy, about 93 grams. Battery brings it up to 113. Canopy brings us up to 119, 120, somewhere in there. 4.2 ounces. First test flight of the OMP M1. I've obviously done my control checks just to make sure everything's working in the right direction, and we've done a range check. Everything checks out. So we'll see how she goes here. Amazing. So that's hands off. Okay, this is my really tame flight mode. I've got about 50% dual rate. I cannot believe how fluid it is. And the other thing that you can't get over with these things is just how quiet they are. At distance, you can't even hear it. There's the yaw rate. Try that again here. Good tail lock. And I like the level 5 setup right out of the box. Again, I haven't adjusted anything. And I don't know what it is about OMP's secret sauce in their PID algorithms. I just cannot get over how fluid these are. But let's go into a higher head speed and see if we can do some acro. But for tame flying, just beautiful. Well, I think I've got a good contender here for the little T-Rex's replacement. This is just amazing. Okay, we'll go into a higher head speed. Do some pitch pumps. Tail is not blowing out. I'm going to go into my middle rates. A little bit too aggressive head speed for me. I'm going to go down a little bit more. We'll try it again. Haven't flown in a while. You get rusty fast. Oh, so fluid. Now I'll go right to full high rates. Cannot get over how quiet it is, but you can really hear the little blades barking. Yeah, if you like flying the M2, I think you'll like flying these. The M1, it's amazing. Whoa, that was close. Cameraman, need to change your underwear there, partner? Oh, wow. Yeah, that gets the heart pounding. Love it. And now we're back to full tameness. Love it. So we'll go inside. I'll give you my final thoughts on the little M1 after its first test flight here, which almost ended in catastrophe, but we saved her. Just amazing. Awesome. Well, that was just a little bit too much fun, folks. What can I say about the M1? Another home run there, OMPHobby. You knocked it out of the park again. Just like I said last year when I did the original M2. Definitely my favorite micro heli so far. And as much as I liked my little T-Rex, I think this is definitely going to be the new yard flyer. I just can't get over how smooth it was. There was no nervousness. It was so predictable. For me, in the tamer flying in my sports setup, it was just about perfect. It definitely has more power than the T-Rex does. Flight times, in case you're curious, I had my flight timer set to 4 minutes, which is the same as my T-Rex 150X. And after a 4-minute flight, the battery is pretty much 80% depleted. Open circuit voltage is 3.77 volts per cell. So that's about an 80% discharged battery. So 4 minutes, I wasn't flying hard, aggressive the whole time. I had the head speed high for maybe half the flight. So if you were to fly full hard 3D, probably 2.5, 3 minutes. If you were to fly tame, easily 5 minutes, which is pretty standard for a heli of this size. I'm totally impressed. If you're thinking of getting an M1 or you're curious about them, hopefully this little review gave you a little more information on them. But OMPHobby, winner, winner, pizza dinner. You did it again. Cheers, folks. Happy flights. We'll see you next time.